Okay, so continuing standard deviation, I said before that the sigma was the standard deviation of a population. So that was the standard deviation of a population. And I said that S was the standard deviation of a sample. Now, slightly confusingly, they don't actually have the same formula. And there's going to be a bit of a hand-wavy type situation. But the formula becomes, so it's S equals the square root of the sum of, so this is the same thing as mu, but for a sample we say that the average is x with a bar on it. And it's going to be n minus 1. I think it might be a capital N minus 1, but it's the same idea. It's going to be a number of things. And what the minus 1 does, it tends to make it bigger, because in a sample, things tend to be closer to each other than they are to the population. So we tend to be underestimating the standard deviation. If the n was very big, so if your sample size was fairly large, dividing by 1,000 or dividing by 999 would not make a difference. If the sample size was small, let's say you only had 4 points in the sample, dividing by 4 or dividing by 3 would have a very large effect. This is not, this is more of a convention type situation. And that's all I'm going to say about standard. How would you know whether to use the standard deviation of a population or standard deviation of a sample? That would be based on the actual question itself. So if it's if the question is that it talks about a population, so everybody in a population, that's going to be the normal formula. If it's if the question describes a sample, it's going to be a sample. At the end of that, there's going to be something called, the next concept is something called a variance. So the symbol for a variance is the standard, that's the actual symbol for a variance. It's the standard deviation squared. And sure enough, the formula is the same thing as the formula for standard deviation, but without the square root, so it's been squared. So it's going to be the sum of the deviation squared over n. The variance doesn't actually represent anything. So the standard deviation represented the average distance from the mean. The deviation squared represents nothing. I mean, the variance represents nothing. Weirdly enough, though, most publications that I've read, when they talk about standard deviation, they actually publish the variance instead. So instead of saying the standard deviation was 3, they'll say the variance is 9. And I'm not totally sure what the reason is for that. I've tried to look it up, and I can't actually find a good reason for it. But that's the way it is. Okay, we're going to do an example now. So example, I don't know, 1 I guess. So number of days in class. We're going to do it with a frequency table. So let's say some kids were there for 85, students I should say, 88, 90, 92, and we'll say that the frequency was 3, 11, 12, 20, and 4. And what I want is I want the standard deviation. So the first thing we're going to have to figure out some values. So we're going to need the n. And to figure out the n, we add up the frequencies. So that's going to give us 15 plus 15 is 30 plus 20. The n is 50. Then we're going to have to find the mean. And the mean's not necessarily that easy. You may or may not recall the mean is going to be this times this, plus this times this, plus this times this, plus this times this, plus this times this, divided by the frequency, which is going to be 82 times 3 plus 85 times 11 plus 80 times 12 plus divided by 50 is 51. That doesn't seem right. 82 times 3 plus 85 times 11. 12. And my calculator, of course, just blanked out on me. Because that's what happens when you're trying to make a lesson. Okay, so I'm getting 88.1. Hopefully I'm right. If I'm wrong, let me know, and we'll go about fixing it in some sort of way. We're going to go for that for now. So the mean is 88.1. Then what we have is, we're going to make our table again. So it's going to be our x minus the mu, the x minus the mu squared, and there's going to be an extra line, which we're going to get to in a second. So what we have is we have our 82, our 85, our 88, our 90, and our 92. And we're going to subtract 80. We're going to subtract the 88.1. So 82 minus 88.1 would be negative 6.1. This one would be negative 3.1. This would be minus 0.1 plus 1.9 plus 3.9. And if we square it, this would be 9.61, 0.01, 3.61. I do these in my head. 6.1 squared is 37.21. 2.9 squared, 15.21. Now, what's going to happen though is we had this 82 3 times, and we had this 85 11 times, and we had this, this 9.61 deviation, we had it 11 times. We had this deviation that many times. So we're going to take, this deviation happened 3 times. So we're going to actually take this deviation and multiply it by the frequency. So what we're going to get is, we're going to have 3 times the deviation. So that's going to be 37.21 times 3. So that's going to be 111.63. And then the 9.61 is going to be multiplied by 11. Did that work out? That's right, I put a 0 in front, but it still worked. That's a solid calculator. This one I could do in my head. 12 point that's going to be 0.12. 20 times 3.61, 72.2. And 4, actually, that's going to be 60.84. So then what we do is we add these all up. So we're going to get 111.63 plus 105.71 plus 0.12. So I got 350.5. So now, when we do our formula, the standard deviation is going to be the sum of the frequencies times the deviations squared divided by the total number of things, which in this case is going to be the sum of the frequencies. Or in other words, it's going to be the square root of 350.5 divided by 50 which is going to be the square root of 7.01, which is 2.65. And there we go. So the standard deviation of this frequency table is 2.65. Now, we could have a situation where, for example, we might have, and the frequency, so let's say we might have a range. So 0 to 10, 10 to 20, 20 to 30, 30 to 40, and I'm not going to actually calculate this, so the numbers don't really matter. What would we do in this case? The way we do a range is kind of like what we did for mean, median, and mode. We're going to assume that every point in the range is at the midpoint. So we would assume that we have 42 values of 5, and 8 values of 15, and 3 values of 25, and 2 values of 35. And then we would calculate the standard deviation, just like we did for the other one. Okay. And that's standard deviation.